Are you new to ham radio? Perhaps you just got your technician's license and you're trying to program a local repeater into your equipment for the first time? Are you a little bit confused perhaps on the difference between a DMR repeater versus an FM analog repeater? Do you know the difference between a PL tone versus a tone squelch? Well, if these are the things you're trying to get your brain wrapped around, like I was when I began, then you need to watch this video. This is part one of a two-part series. Part one, I'm going to cover the analog or your FM repeaters. I'll go over the terminology, what's the difference between the different tones, where do you go to get the information, and how to program your radio. Part two, I'm going to cover more about the DMR, and I'll talk specifically about those type of repeaters and the information that's required to program your radios. They're quite different. So if this is something that you're interested in, let's get started. Hey, welcome to another episode of Ham Radio Made Simple. This is MJ, KO4TWA. If you like these videos and want others to find it, hit the like button or the subscribe button. That's the only way others are going to be able to find this particular YouTube channel. It's hard in the beginning to get people to find it, and I get some people saying it was hard to find you, but really enjoyed it. You can help them out by hitting the like or the subscribe button. Not for me, but for those who are wanting this type of information. I've broken this into a two-part series on repeaters for beginners. Part one, strictly dealing with your analog or your FM, UHF, VHF repeaters. Part two is going to be to your DMR repeaters. It's a different way of setting up. It's a different language. And I don't want to give you information overload. So what will I be covering today? What is a repeater? How does it operate? Frequencies and offsets, PL tones, tone squelches. What are they? What's the difference? How do you use them? Where do you find the information? Programming your radio. What's the type of information you need to do to enter it in? And I'll go over a quick summary again, just reminding you of the key essential points out of this video in order for you to have a better experience with ham radio. The reason I do these channels, I'm trying to give you a tool to navigate. I call it through information gaps. As still a new user of ham radio, I find that there's a lot of information gaps that people leave out, and it's very frustrating when you only have 80% of the information. I'm going to help you find and navigate you to the information close to 100% as I can, so it makes your experience much more positive. My goal is also to be non-technical, to make it easy to understand. So what is an analog repeater? It's a device that extends the range of your weak FM signal. It's going to rebroadcast it in order to cover a much larger geographical area. So if you look here, for example, I'm in my home with my mobile base station, my ICOM 5100. And if I wanted to do a simplex call, I can maybe get a couple miles. That's all I'm going to get. But when I use a repeater that's 4 miles away, or 5 miles away in my particular case, could be further than that, it's going to take my weak signal, and because the antenna is higher up, it's going to rebroadcast it out to a much larger geographical coverage. And so I've got people now 15, 25, 30 miles away being able to easily hear and have a conversation by the use of the repeaters. That's why in ham radio, repeaters are probably used over 90, 95% of the time. Now, who owns them? Well, most of them are owned and managed by ham radio clubs. Typically, they make it open to anyone who wants to use it. They're trying to promote ham radio. Private individuals may limit who can use it, and some don't. They don't care. So when we talk about an analog repeater, analog operates in the FM mode, and you can only have one conversation at a time. Now, the majority of ham radio repeaters are analog, and the majority of analog repeaters are they call them the 440 repeaters, or what's known as the 70 centimeter repeaters. Now, the DMR is different in the sense that you can have more than one conversation at a time, but you have to use a DMR repeater. You cannot do digital mobile radio on an analog, nor can you do analog on a digital mobile radio repeater. So each of them are specific to their own. What can I expect as far as my distance? Well, we have to break this down into two areas. The average reach to the repeater, and that can vary anywhere from 2 miles, 20 miles plus. And that depends on a couple factors. Are you using an HT or a handy talkie or the handheld one? And are you using the stock antenna? Because if you are, you just lost a lot of distance. one of the most important things I'm going to tell you from this video right now is whatever radio you own, ditch the antenna unless you live real close to a bunch of repeaters, which most of you don't. But if you don't live close to those repeaters, get a better quality antenna, because it's better to have a better antenna than a better radio in order to be able to operate successfully in this area. And I'll talk a little bit more about an antenna that I use. And again, not compensated at all. But again, if someone would have told me this in the beginning, would have saved me a lot of frustration. So your radio power can vary also. When you have your handheld, you're going to get anywhere from 2 watts to maybe 7 or 8 watts, versus when you're looking at your base station units, you're talking 25 to 65 watts that's in there. And if you're mobile in your car, then your antenna that's on your car is going to be better than your antenna that's on your HT. So there's a lot of factors that come into play. Also, topography is going to affect it. What do I mean by that? I live at the base of a hill in a subdivision, and I can't hit repeaters too well going north because that's the direction of the hill. My antenna, outside antenna, which is a really good antenna, is, even though it's about 25, 30 feet in the air, cannot get past the top of the hill and then the houses on that side. So I'm blocked. I'm being interfered from my signals from that hill that's just right there. If I go south, east, or west, I can go much, much further because I don't have the hill to deal with. So be aware that does play a major factor in your ability to reach a repeater. Now, average reach from the repeater. So in other words, that repeater reaching, you're hearing it on your phone. It typically 5 to 50 miles. I've heard of someone 65 miles on top of a hill. They lived and everything else was down below them, and they were able to go 65 miles to be able to hit a repeater. But again, that's where they had the topography working in their favor. So if we look at a map, for example, right in here, some of these repeaters will have a much greater reach. Now, this is part of the Carolina 440 system. These are linked repeaters, and it's given me a huge, maybe 150, 200-mile radius coverage versus this one's a 5-mile, which happens to be a private local repeater in my area. No two repeaters are the same. If you can hear the repeater but are having trouble reaching it, you may sound like bacon. And you'll even hear, or bacon frying. You'll hear the term, the side people come back, say, oh, you're coming across as bacon. What they mean, it's crackling. And not uncommon, they can hear the repeater perfectly clear. Transmitting to the repeater is a different story, but from the repeater, they hear it clear, and they just sound like bacon. If that happens, a couple things. Get a better antenna, or just change your location. So when we talk about setting up these repeaters, what all is involved in it? Well, first of all, your antennas are going to be located on a high hill, high point, so top of a building, top of a water tower, mountains, etc., and it extends the reach, dramatically. You could also notice here that you'll see a bunch of antennas on top of buildings and stuff. They're all competing for space, but the purpose is that high points allow the greatest distance to travel of your FM waves. So power can also determine it. Each repeater uses a different power output. Some will do 10, 15 watts. Others will do 200 watts. Makes a big difference. So there are things that play into consideration as far as for repeaters to be accessible to those who are out in the communities. You're also going to find that the equipment to operate that are typically close by. It's going to be a small shack like you might see right here. Guy working on it, doesn't need much space. It could be in someone's house. It could be these sheds that are up on top of these hills. And it's also utility room in a building. It doesn't need a full-size office space in order to do it. So what type of equipment is in these repeater shacks or rooms? Typically what you're going to find is your duplexers. And what are the duplexers? Well, this allows to be able to transmit and receive on different frequencies. So this may be your transmit, this may be your receive, and we'll get more into that, it'll make more sense. They're about 3 feet tall and they're pretty heavy. What you're going to find most common out there is probably an older repeater box that you see out there, because from my experience in looking at a lot of these repeaters, it looks like a lot of them are being held together by duct tape. The buildings that they're in look really sketchy. But listen, clubs are operating on a thin margin here, so they make do with what they have, and I'm grateful for the very fact that I can even reach and have access to these repeaters. That's typically common. Your newer ones, especially when you get into DMR, they're going to look more slick like that. They also have the controller. The repeater controller is built in versus a separate device that has to be added on top of this. All going to require a power supply box. There's other things that they may have in there. They're going to have band filters. They're going to have switches, remote access points to be able to look at the repeater from back in their comfort of their home office. Now, a lot of these will have battery backup, but best case is 24 hours, unless it's e-powered, which means solar powered, and they're constantly being recharged. If the power goes out, you can count on most of these repeaters operating for 24 hours on their battery. They'll cut the power down maybe to like 10 watts, so the coverage won't be as good, but they'll still stay in operation. If they want to go past the battery life, they have to have a generator on site or haul a generator in, keep bringing the fuel, and keep powering the batteries. So if you're a prepper and you're looking at this, unless there's basically what is known as an e-powered or solar backup powered repeater, a lot of these are going to go down after 24 hours after to maybe 3 or 4 days later. Someone will get tired hauling the gas up to keep the generators going. And all the repeater stations that we're talking about are either 2 meter or 70 centimeter, because most of us have what is known as dual band radios, and it's either 2 meter or 70 centimeter bands. When we look at repeater information, there's key pieces that you're going to need to be able to program your radio, and I'll show you where you can get them from. So the first type of information you need to know is, what is the mode of that repeater? Is it an analog or is it a digital? Because if I'm doing digital, I have to hit a digital repeater. If I'm doing analog or FM, I have to use an analog repeater. And repeater book will break that down. What's the frequency of that repeater? What is the offset of the frequency? And what are the tones that you have to use? So when you look at repeaterbook.com, I did a video to show you exactly how to use it, to find all this information the easiest possible way, and even how to export it. D-Star, the reason I included D-Star in here, it's the only place that I can find that really had an adequate list of tone squelch listing for repeaters in the country. It doesn't have every single state, but it's better than nothing. Also, when we look at this, we're going to have to find the two frequencies being used. So remember a couple slides ago, I talked about the duplexer, and you saw that 4 gray tubes together. 2 of them are for your downlink, and 2 of them are for your uplink. That's why they call it duplex or duplexer. So your repeater downlink is your radio's receive frequency. So think of it as it's coming down to you, you're receiving it. Whereas the uplink is you're transmitting up to the repeater. So downlink is your receive, your uplink is your transmit frequency. And you can see the examples of this. Now we're going to get into what is known as basically frequency offsets. What are they? 70 centimeter, it's either going to be plus or minus 5 megahertz. And for an example here, you can see the offset on the, again, you're showing here a 70 centimeter one, plus or minus 5, and it's actually calculated in. That's plus 5, so that's 446. When you're doing the 2 meter one, it's plus or minus 0.6 megahertz. So if we look over here, the offset is minus 0.6. So 145.1900 minus 0.6 is 144.5900. This is your offset. More things to know are, what are the tones? Here are the possible tone lists that's available for repeaters to use to program in order for you to access their repeater. So what's confusing is a lot of people will say tones. Some people say PL tones, which stands for private line, came from Motorola a decade or 2 ago, or CTCSS. Well, what do they mean? They're all the same thing, but essentially it's a continuous tone coded squelch system. They're adding a lower frequency audio tone to the voice that cannot be picked up by human hearing. So think of it this way. It is a subaudible password. So when you're programming your local repeater into your radio, it's looking for a password. Well, that's built into the tone. That's what that tone is. It's the password to say, okay, I can hear that tone. You can't, but I can hear that tone. So the repeater's saying, come on in. You can be used on this repeater. That's all it is. Now, a tone squelch is one of those things no one tells you about until you run into trouble with your radio. And you're going, how come I can hear that repeater crystal clear, but no one can hear me? Well, it's probably because it requires, instead of a tone setting, it requires a tone squelch setting within your radio. So when there are two repeaters with the same tone using tone squelch, it will prevent the other repeater from unmuting your receiver. Bottom line is, two repeaters competing in the same tone, it's a way to distinguish one from the other. And you say, okay, so we don't have confusion. You're going to know it's this particular repeater that you're hitting. I'm going to require a tone squelch setting. You hit that, and then it differentiates me from the other one that sounds a lot like me in a different location. So about 1 out of 10 repeaters out there today require the tone squelch. A lot of the information you're going to get from is repeaterbook.com, and I suggest you watch the video. Again, I walk you through the whole process and how to get the information out of there. So when you get into Repeater Book, you're going to see something typical as this. You're going to see the frequency, the offset, the tone up and down, location, the county, the call, the use, and the modes. What do you need from this particular sheet? Well, let's look at the frequency. We need to find what the frequency is. Then we're going to need to know what the offset is. And so if I'm looking at an offset, if I click on the hyperlink right here, it's going to go to that screen that was earlier in that showed you the offsets. But if you don't want to click it and you don't want to try to find out what it is, you can just do the math. You can take this frequency and minus 0.6. That's the offset. And it's going to show you, okay, here are my tones. This is my uplink and this is my downlink. 131.8, 131.8. Good to go. Oh, by the way, make sure you look at the modes because they're all different type of modes. When you see DMR, what you're seeing in here is digital mobile radio, and you notice here it's a whole different language. You're going to get into color codes, talk groups, a whole different language. So another video we'll talk about that. But you're going to want to find if it's FM. This is my analog. Focus on that for now. Later on, if I'm doing D-Star system, which is their digital version of it, of a DMR, it has to be a specific repeater that works for the D-Star equipment, or the Yaesu Fusion is their own equipment. It has to go to a specific repeater that uses their protocols. So ICOM protocols, Yaesu protocols, let's see, DMR would be Bofang and Anytone protocols, which is more of an open standard that's out there. Repeater tones. When we talk about tone squelch, this is what I sort in the video, and I'm looking for specifically right in here. These are the repeaters that are for, like, for example, Angier. Here is the repeater. Here's the frequency. This one requires a tone squelch. This is a great tool. It saves you the frustration of not being able to communicate on that repeater. So these are the must-haves, again, when you're programming your radios. Find the nearest analog repeater if you're doing analog, or the nearest digital if you're doing digital. Decide if you want to do 2 meters or the 70 centimeters. You can do either or, it doesn't matter. You're going to have to find the frequency with the offsets. You're going to have to know the tone, and you're going to have to know if a tone squelch is required. So there's 2 ways to program your radio. First ways you can do is software. Now, Chirp is open source software. It's free. You can find it on the internet. Just Google it. Typically, that's what Bofang, if you're using software to program your radio, you would use Chirp software. If you're using BTEC and Anytone, the CPS is the one that you want to use. Now, you don't have to have the learning curve of doing software. You could do the front panel, but my suggestion is this. If you're only putting in 2 or 3 repeaters and some simplex frequencies in it, do it by the front panel. A lot easier, shorter learning curve. You don't have to do it. But in my case, I think I've got like 25 repeaters programmed into my area, into my radio. Software is the best way of doing that. And I can host a lot of other functions. I can set all of the display functions, the key functions, and everything done through the software. Your more expensive radios are built to basically operate off the software. Your lower end radios, cheaper ones, are built to operate off the front panel. But if you're doing direct input, check your manual. There are YouTubes specific to your model. And make sure you try at least 1 repeater before you continue doing the programming to make sure that it works. So when we look at computer programming, for example here, this happens to be the CPS software unit. If I'm doing analog, I got to put the receive and the transmit frequency in, and they don't automatically calculate it for you. I have to put whether it's the decode, which is the tone from the repeater to your radio, which is your downlink, which you see over here, and the encode tone to the repeater from your radio, which is right over here. So, and if a tone squelch is required, this is where it goes. Now, this is where no one really talked about. Again, the gap of information I'm trying to save you from is no one talks about tone squelch, where to put it in. You can watch a lot of these videos on it, and they don't talk about it. So when in doubt, put in the tone squelch. This is how you would typically program within CPS an analog repeater radio. You mark analog, you can put turbo because it's typically further. Turbo means the greatest power that you want to put it at. 25K is a wider band, analog local, and off you go. Analog local is basically for my scan list, which is another video. You can see this can get very complicated very quickly. So if I'm looking, for example, at the exceptions, I call it, from repeater book when you're pulling at it, let's just look at, for example, I see a CSQ. Well, what does that mean? It means no downlink tone is required. You can just leave that blank. If it makes sense, if you're thinking about this as a subaudible password, on the tone up, when I'm transmitting, is when that tone is going to the repeater. I'm giving them the subaudible password that's saying, oh, I recognize that code. Come on in, use the repeater. So that's why you're going to see it more often on the tone up. You see it more often on both, but if it's going to be on one, it's usually on the tone up. CSQ says don't necessarily require it. I don't care at that point. Next is typical, is what you see right here. Pretty straightforward, frequency, offset, and the two tones. Makes it simple. But when you start getting into digital, CC1, what does that mean? Well, another video, but that means color code 1. It's a whole different way of programming digital than analog, completely separate. When there's no tones, which means there's blank, then what you see in here, there's no uplink, no downlink. Well, you don't have to put any tones in. It's simply putting in the frequency and the offset. That's it. So if I was doing a Bofang, for example, I just want to show you how language is used differently and the terms are used differently depending on the manufacturer that's out there. They operate the same principle, but how they describe it and the terms they use is different. First of all, everyone has to do a VFO mode. This mode, when you have it on your radio, allows you to tune to a specific frequency. Think of it as dialing on an AM, FM radio. You're going back and forth. You're going to a channel. In ham radio, you don't operate like this. You're only going there to program into a memory a specific repeater or a specific channel. You don't tune. You only use the tuning, the frequency, to be able to program a repeater or a channel. So you want to enter the repeater frequency, which we got from Repeater Book. This is how they look at it. We want to put in the tone. So they're going to call it T-CTCS. This is the PL tone, the CTCSS tone, or the basically tone. This is the description Bofang uses to enter that in. So this is where we put like the 82.5, the 107.2 that came from the repeater book that I just showed you. But my point is this. They call it something different than what ICOM does, what Yaesu does. They all do it differently. So it can be confusing, but it does require you to put the tone in. As far as putting the frequency offset, Bofang uses SFT-D. That is a frequency offset. And this is where it can be, again, as we mentioned, 70 meters, different from the 2 meter. It's plus or minus. Now, if I look at my radio, which is a higher end radio, this is like a 50-watt mobile base station unit here. Again, same principle. I have to go to the VF mode and tune in the frequency. Get to the right frequency, and then I can start programming it. It automatically calculates the dupe. Is it a plus or is it a minus? If I can hit plus, or if there's none, I just do 0 on it. Repeater tone. Essentially, do I do plus or minus, up or down? I just scroll through basically on the repeater tone. It's all pre-programmed. All of those possible repeater tone possibilities are in the ICOM software. And here's where it gets into 9 out of 10 times, tone works. 1 out of 10 times, it's going to require me to select tone squelch. So it is separate. It's most of the time default to this. But if you can't be heard, go back to your radio and change it to a tone squelch. So how do you hit a repeater? Most important thing, as I mentioned earlier, is a good antenna is critical. A bad radio with a good antenna is better than a great radio with a bad antenna, most of the times. And so stock antenna, poor to average, replace it. What I would recommend, and I don't get any money from this, no promotion. Again, I'm trying to save you time and frustration from experiencing all of this. I mean, I even upgraded to a slightly better antenna, Nagoya 701 from Anytone, and it was okay. But someone recommended using the signal stick, and all of a sudden, man, I was getting twice the distance, picking up so many more repeaters around the area. I was like, wow, it changed everything. So it's a longer antenna, but you can fold it, you can bend it, it returns back to its memory, comes in different colors. Typically, though, it goes for about $25. That includes shipping as the time of this recording. With inflation, guys, who knows what it's going to be tomorrow. Key is to make sure that your SMA connector from your radio works with the connector from Signal Stick. They offer a male, female SMA, BNC, which is a quick disconnect system, which I use. Again, a totally different conversation, but I have it so that I can change the antenna, take it off in a matter of a twist without having to unscrew it and over long-term damaging the threads off the SMA. If you're interested and want more information on that, hit the comments below and I'll get back to you. So, summary of analog repeater, things you need to walk away with from this video is, okay, so what? What matters from this? There are different types of repeaters. There's FM, there's digital, but within the FM, analog, you're going to pick the 2 meter or the 70 centimeter. The majority of us are dealing with dual band radios. Those are the 2 bands. Distance to the repeater matters, but not all repeaters have the same power, same height, same antenna, so you're going to have a different experience. Don't think of them as equal. There are going to be differences between the repeaters that one might be closer to you, but you may not be able to reach it as easy as the one further down because it has a higher antenna and more power. Frequency with offset. Remember, it's different from a 70 centimeter than it is from a 2 meter. When we talk about PL tones and CTCSS or tones in general, you can hear the term transmit or receive, encode or decode, uplink or downlink. Just understand that these are the same. This is all going one direction, and these are the same. They're going in a different direction. This is transmitting, and these are all here being received. Question mark, is a tone squelch required? You're going to find out. Antenna, antenna, antenna. Walk away from this video. Make sure you get a good antenna. I can tell you from personal experience of listening to new ham radio operators try to join a net, and they sound like bacon. They can't be heard. They can hear us perfectly clear. They try to get to a window, maybe a little bit better improvement, and then they're actually standing out in their backyard trying to talk for 35 minutes in bad weather to be able to talk to someone on the net. If they simply would have bought a signal stick antenna, got close to the window, they wouldn't have had this problem. And the other thing is find a radio easy to program. The cheaper end radios are more difficult to program. You get what you pay for. You pay more for a radio, the front panel is easier to program, and they have software and cables options to be able to connect to your computer and program it that way. Don't cheap out on the radio. Don't buy the lowest end. You don't have to buy the highest end, but get something that's going to make it easier for you to use, to program, and to have success with. So what's up next? Short videos are coming out with this one. I'm going to do on repeater book, and I'm going to take you through how to find the closest ones in your area, how to export, etc. I'm going to take you through D-Star and through Excel and how to take all that information over, export it, and sort and find which repeaters. Hopefully it's listing your state, and it's going to show you which ones require a tone squelch. DMR repeaters is the next one that I'm working on right now because it has its own language and own way of doing things. And I'll get into finally simplex frequencies, analog versus digital. You do it differently, and there are multiple ways to do digital versus analog. So hopefully that'll help clarify it because it was confusing for me and confusing for others when you talk about digital simplex frequencies. So I'll explain all of that. So I hope you've enjoyed this video enough to hit the like button and the subscribe button. and that others can find it a little bit easier and make it a better experience for them too. So this is MJ, KO4 TWA, with Ham Radio Made Simple, out.